Go, John.
Okay, good morning, everyone, and welcome back to the Overberg Zoom program. I trust you had a good holiday during July. We enjoyed the break, and it's really nice to kick off again this morning with a local from just down the road in Pringle Bay, Dr. Roger Parsons. Roger grew up in East London, where he matriculated from Selborne College, and then he went to the Rhodes University, which we all know well. He completed a BSc Honours in Geology and Geography before embarking on an MSc in Geohydrology, where he investigated groundwater resources to supplement Craft Renet's water supply. In 2014, he was awarded a PhD degree from the University of the Free State for research on groundwater sustainability in Groenvlei, a lacustrine wetland located near Sedgefield. He's worked for the Department of Water Affairs and CSIR before establishing Parsons and Associates, a specialist groundwater consultancy in 1996. He has a broad range of professional interests, including resource development, groundwater contamination, and the integrated role of groundwater in the environment. For the last 4 years, Roger has been assisting the Western Cape government develop groundwater supplies and critical infrastructure to combat the threat posed by our drought-driven failing municipal water supplies. So we really look forward to hearing you today, Roger, and over to you. Thanks.
Thank you very much, John. Let me see if I can do this thing without any pain. Okay, are we up and running?
Perfect, go for it.
Good.
Thank you very much. Good morning, everyone. Thank you very much for the invite to be able to come and address you today on Arabella Country Estate. I have to admit that this is my first Zoom meeting. After all this time, this is the first Zoom presentation that I'm actually giving. So I'm asking for forgiveness if I bumble along a little bit. Off the bat, you'll see that my maths isn't very good. That I've called this 21 years of groundwater monitoring at Arabella Country Estate, and I think we're getting closer to something like 24. But it's a title that I've been inspired by. The work that we did at Arabella, starting in the 1990s. We put in quite an extensive monitoring program, and it remained one of the best monitoring programs for quite a long time. But what we do now has really become quite commonplace. So I've always had the need to give this presentation of 21 years of groundwater monitoring. Right at the outset, I'd like to acknowledge Arabella Country Estate and the components of that. In the time that I've worked at Arabella, I've been through 4 state managers. And all of them have seen the need to manage their groundwater properly. And I hope that'll come through in my presentation. I'd like to specifically thank William Lane for the support that he gives me. William is he's the maintenance manager at Arabella, and he does an absolutely wonderful job in all my projects that I've done. I've always referred to the man. You've got to go and find the man. And sometimes he's a senior person, and sometimes he's not a senior person. William is obviously one of the more senior people that knows exactly what's going on at Arabella. But the real man is a chap by the name of Petrus Brainkies that I've got showing in the slide here. So every couple of months I go along to Arabella, I do a groundwater monitoring run, and Petrus accompanies me on that trip, and he's a wonderful source of information to understand what's going on, what the challenges are that Arabella is facing at the time. In my last trip a couple of days ago, he was really proud to announce that the British Lions are staying at Arabella, which I didn't know. And then I think the last particular word of thanks is an acknowledgement to my colleague John Weaver, who's sitting in here today. My involvement at Arabella started with a trip to Arabella with John when I was still working for the CSR, and we were asked to go and have a look at what we thought of the groundwater prospects on this derelict piece of land. When I started Parsons and Associates, I got a direct appointment to do that, but John was there on day one when I started on this journey. This is a picture that many of you will be familiar with, but it's sort of slowly starting to recede in our minds that not that long ago, Theewaterskloof Dam was operating at somewhere around about 13%. It was Cape Town was about to go into a day zero scenario. So groundwater came to the fore, and it was on a lot of everyone's lips. We were starting to think about, well, how is the population of Cape Town going to be supplied with water? And the city was talking about pods, and we had to go and fetch water in buckets and barrels and containers. And so groundwater is very much at the forefront. During that time, though, there was a lot of negative comment about groundwater, how it's an unsustainable resource and it's badly managed and so on. And I hope what I can do today is demonstrate to you that that's not true. I'd like to put forward Arabella as a case study of where things can be done properly and where the groundwater resources can be used sustainably to the benefit of a whole lot of people. This is a slide that Dylan Blake might talk about in the next presentation, where they were drilling boreholes up around the Stellenbosch Dam, and you'll see here all these people looking on and having an explanation about what's going on and so on. And I know that the drilling they did up there was put under a microscope all the time. But let's see how Arabella stood out. So to give us a location, Arabella Country Estate is located at the end of the R44 to the east of Kleinmond, which is situated here, and to the west of Hermanus. It's located in this valley, the Bot River Valley, and this is the Bot River Lagoon that many of us drive past all the time. Back in the early 1990s, it was really a derelict piece of land. You can see this is a photograph, I think, that was taken about 1984. You'll see that there was some agricultural activities, but when the idea was mooted to build this estate there, it was really quite a derelict piece of land with lots of alien vegetation and so on. And it's always amazed me how people see things differently. As a hydrogeologist, you know, I love seeing geology, I love seeing rocks, I love seeing water and these kind of things. But other people have the vision to see a derelict piece of land and change it into this wonderful oasis. It wasn't a smooth process. There were a couple of developers that were involved, and every so often the people we were dealing with would change, or the name of the development would change. I think it started out as Laughing Waters, then it moved on to Hermanus River Country Estate, I think, and it's been quite stable at Arabella Country Estate for the last while. And Arabella Country Estates contains three different components. One, it's the hotel. Two, it's the golf course, and three, it's the residents that have houses in the estate. But they operate and supplied with water from the same source. All right. So what was the hydrogeological target that we were after? And what I've got here is an oblique aerial or oblique satellite image from Google Earth, where I've put in the production borehole so that we can see exactly where we are. But if you let your mind go a little bit, you can see the ridge on the western side, and you can see the ridge on the eastern side, and you'll notice that there's very little agricultural activity on what I will show you is the Table Mountain group. So over that image, I draped the 1 to 250,000 geological map. And the key feature that we see is this, this major fault that runs here, and that is the western limb. And we see another major fault system that runs over here on the eastern side. So outside of the valley, we have Table Mountain Group, and on the inside of the valley, we have Borkerveld. And the agricultural practice is all on the softer, more erodible and soil-rich Borkerveld, where the water is stored in the harder, very competent quartzites of the Table Mountain Group. So here we the target that we have is this this fault on the western limb of what is really a classic Horston Graben structure, and we're dealing with the Overberg. So the Overberg doesn't have it generally doesn't have a good reputation, with the idea that it's iron rich, but in recent times more and more groundwater has been developed out of this formation, and we're learning to deal with the iron that it does contain. Right, so just to remind us that we're not dealing with a primary aquifer system. The primary aquifer system is where water moves between the individual sand grains or cobbles or whatever, but there's no secondary processes that are required to enhance the hydrogeological properties. In this instance, we're dealing with a fractured rock aquifer, where the water moves in openings created by some sort of secondary process. In this case, faulting, but it could also be folding, it could be bedding planes, it could be weathering and so on. But here we're dealing specifically with a fault. So I heard earlier that we've got a geophysicist in the audience, and I often get nervous because I'm far from being a geophysicist, but geophysics is a tool that we use to, like any geologist, to try and understand what's going on. And I'm quite proud of this picture because I dug it out of my original files. This was from project number 3 of Parsons and Associates, where we were asked by GIB Africa to go and do some resistivity soundings and some profiling so that we could pinpoint the fault and help cite some of the initial exploration boreholes. And if you look very closely, you can see some little lines around the north arrow. You can see some little lines around the scale. And what this was is, this was way before we had the computing abilities we had today, where this was a cutout of an orthophoto map where I stuck on labels, I stuck on the scale, the north arrow, and you tipexed around the edges so that they didn't show clearly when you photostated. And this is the original masterpiece that went into my report in 1998. You'll see that a couple of the labels have missing, but it just shows you the technology we were doing. I clearly remember hiring resistivity equipment from John Weaver to go and do this work because I didn't have any of my own. But from this work, I was able to produce this conceptual model where I thought we were quite easily able to identify where the fault was, with the Borkerveld having much lower resistivity than the Table Mountain Group. And the contrast was quite sharp, and we could identify this fault to a fairly high degree of accuracy. It was also helped by topography and soil color. But this feels a little bit like it was back in the day, because since then we've moved on to much fancier, much quicker, much better resistivity tools. So this is a traverse that is produced from a multi-electrode Lund system, and we've been using these quite routinely across Arabella to try and pinpoint the fault as our exploration grew, to get more and more water for the facility and to improve their water security. And because of that contrast, we were quite easily able to map the fault. And we also started targeting some fracture zones that came off the fault system. And you'll see that almost all of the production boreholes target the fault. And then we went off the range on 2 occasions to drill this borehole and this borehole, which I'll explain in a moment. All right, so the first exploration borehole was drilled in 1997. It was driven by Dr. John McStay of Gib Africa, or whichever version it was at that stage. And he, using Fairbrother Drilling Company, they put down 2 boreholes. They were quite shallow boreholes, and they were able to show that there's good groundwater resources to be had out of that fault system. The boreholes weren't very well constructed, and we did some pump tests on them that showed that there was quite a lot of losses because of this construction. But they were the start of the process of developing a water supply for Arabella. In 1998, we sited the first 2 boreholes, borehole LLBH3 and LLBH4, and from now on I'll just talk about borehole 1, 2, 3. I'll drop the LL. LL stands for Laughing Waters, which is the name of the farm. We drilled these boreholes down to about 100 meters, and both of them were what I term very high yielding, 15 to 20 liters a second. Because we were dealing with an estate that was quite remote and didn't have any backup water supplies, the first 2 production boreholes that we drilled were both fitted with PVC casing with 1 millimeter slots, as shown here in the picture, and then back filled with quite a coarse gravel. And we did this to make sure that the boreholes didn't collapse on us at some point in the future. A borehole like this generally costs about double what an uncased borehole would cost, but it stands to reason that we're drilling into a target where the rock is broken. It's not solid, and it's very surprising that we get so few instances where rocks dislodge and they block being able to pull out the pump and so on. So right up front, we took this fairly conservative approach to make sure that the integrity of the boreholes remained in place. So we pump tested these holes, and these 2 boreholes were the start of Arabella's water supply, and they still remain very important to Arabella today, almost 25 years later. Quite soon in the process, we learned that we hadn't really got our sums right, because we were given a volume of water that we had to meet, but we weren't told that volume of water had to be met in a fairly short space of time in summer when irrigation was taking place. So both boreholes were put under a little bit of strain, and it was decided in 1999 to drill a 3rd production borehole. And this was sited off the fault a little bit further away on a fracture. And the reason we wanted to do that is we didn't really understand the hydrogeological performance of the fault, and we wanted to try and tap another part of the aquifer system. And we wanted the borehole to be quite close, because one of the big expenses of any groundwater scheme is not really the drilling, but it's the pipeline and getting electricity to those points. So we drilled this fairly close. It wasn't a particularly outstanding borehole, but it was certainly good enough to make a contribution to the state's water supply. We had 2 further drilling exercises. In 2003, we drilled another 2 boreholes, drilling borehole 6 and 7. Again, they were quite nice yields at about 10 liters a second. These ones we pushed to a much greater depth, 220 to 250 meters. And I remember sitting in my office in Somerset West at that stage, and it was just when cell phones were becoming quite the norm. And clearing my desk when we were down at 250 meters and we still hadn't got a water strike, and really starting to get worried, because our clients were quite demanding and they were quite precise. And when you've spent that amount of money and you haven't got them water, and you say, oh, we know what's going on, it was quite nerve-wracking. But fortunately, at 255 meters, we got a strike of about 10 liters a second, and the day was saved. And then again in 2008, we drilled another 2. So all of these boreholes that we were drilling was about ensuring that Arabella had the water security that our client wanted. So what we've landed up with now is we've landed up with a series of 5 production boreholes. Those are the ones that are marked in red. And we've got 4 other boreholes, 3 of which we monitor very closely. Borehole 8 used to be in production, but we've taken that out of production because of iron bar fouling issues. And borehole 5, we've also taken out of production because once we drilled borehole 6, 7, 8, and 9, it was felt that borehole 5 was very low yielding and we didn't need it. But it is available if we need to bring it back in production for whatever reason. So what you see there is the Arabella well field, and that is what keeps the 3 entities in water after it's been treated. One of the big challenges that we have at Arabella is the quality of the water. So the water is, you'll see just now, is quite acidic, somewhere between 4 and 6. The salinity is very good. It's very, very nice water, but it has this high iron and manganese content. So some of the iron concentrations that we've measured in the past go up to 30 milligrams per liter. And if you remember that you can taste iron when it's above 0.3 milligrams per liter. So that's 2 orders of magnitude more than when you can start tasting it. That's some of the highest iron concentrations I've come across. It's quite interesting though, the picture on the left is in about 2002, soon after Arabella had started, we pulled out the pumps out of boreholes 3 and 4 to check for iron bar fouling, and we didn't find any. That pipe there is pretty darn clean. Yet the 2 pictures in the middle and on the right point to a very high iron content, where the iron is oxidized and it comes out as a very brown color and it coats the inside of pipe. So this is one of the challenges that had to be dealt with. So Gib Africa had a specialist on their team, and they developed a treatment process where there's aeration and settling. It then went through a spray stab system, and then is filtered. And they are able to get the iron concentration down to 0.1 milligrams per liter, so that it doesn't affect the taste of the water or any of the infrastructure. It was quite amusing though that we had to jump through a few hoops, because while we were developing this in the early stages, when Arabella was just brought online, they issue these wonderful white tea robe and white slippers and things. And the first time they went to the laundry, they came back brown. So the poor engineer had to spring into action and make sure that his treatment process worked. But he was able to do that, and the system has worked well since that early hiccup. What the iron does do, though, that it creates big problems for the borehole and the borehole pump. So this is a slide of when we took out the pump out of borehole 8, and you'll see all that residue and iron deposit around the borehole, and that gets into the impellers and it damages the pumps. The pumps don't last very long. We do have the ability to get in there and clean the boreholes. It's quite a manual process. We do it with washing with an acid. We then physically go and scrub the boreholes. We do high pressure jetting, and you'll see that we can go from the situation that we have in the left there to the situation in the right. But what we do know is that it slowly comes back. So this is an ongoing challenge. And just this morning, I had a talk to William Lane, and one of the boreholes has to be put through a borehole rehabilitation process, and the wet end of the pump, the impeller parts, need to be replaced, and so to bring this borehole back into production. But I'm not fully on top of why we get this biofouling, because in actual fact, we've only found it in 3 of the boreholes. The other boreholes haven't shown the same sign. So why are we getting it in some boreholes and not the other? The wisdom is that we should pump the boreholes carefully and not induce oxygen to promote the oxidization of the iron. But that doesn't really work, because the boreholes are treated in the same way, they're managed in the same way. So there's room for learning to be done here to understand this better. All right, so in terms of the volumes that we pump at Arabella, initially we were allowed to pump 293,000 meters cubed per annum, which many of you, it is just a number, but 293,000 is what Water Affairs said we could do. We initially started pumping just boreholes in 3 and 4. We started at 15 liters a second, and we could quite quickly see with the monitoring that we were doing that was a little bit too much, and we reduced it down to 10 liters a second. That pumping rate was driven by what rate the water treatment plant can operate. So one of the management criteria that we have is to make sure that whichever boreholes we're using at any one time have the ability to produce either 36 or 54 meters cubed per hour, and that's what the treatment, that's the rate of the treatment process. In the early days, the owners of Arabella, so we'd gone from the developers now to the owners who were bringing it into implementation. The idea of worrying about groundwater monitoring and water supply was not high on their agenda. They were far more interested in the type of carpets and the quality of the food and the training. So we struggled to get a proper monitoring and management system into place. But all that ended on the 17th of February 2000, when they were called together with us and the engineers to a meeting with John Roberts of the Department of Water Affairs. And he simply just told them, guys, if you want to keep your license, this is how you're going to do it. And he read them the Riot Act, and the next day we had a formal appointment, and nothing has changed since then. They were just simply showing that the monitoring and management of their groundwater scheme was just part of the cost of doing business. But that philosophy has changed quite dramatically, that I now have to go and report to the Homeowners Association on an annual basis on the status of their aquifer and their water supply. And they now fully understand that their investment is totally reliant on the groundwater out of these boreholes, and things have gone along much better since then. Because of a concern about the volume of water and us getting it wrong in the beginning about how much we needed at what time, the application was made to increase the volume from 293,000 to 350,000. And we now have approval to supply 350,000 cubic meters per annum from the boreholes. One of the cleverest things I ever did is when we got the letter from the Department of Water Affairs confirming that, I've kept it in my safe ever since. And every couple of years I get, Roger, do you know where that piece of paper is? Because having a license out of the Department of Water and Sanitation is like gold dust. The water supply was then also supplemented with dam water that was used for irrigation, and some of the effluent is recycled and also used for golf course irrigation. In the beginning, there was very little use during winter because there were few houses and the occupancy of the hotel was low. But most of the water was used for irrigation. And then slowly, as the estate developed, we saw a change in pattern. So the total amount of water and the peak amount of water in summer remained about the same, but slowly we saw the winter demand increasing as more and more people settled in Arabella, and the hotel became more established and better known. Drawing graphs like this is quite time consuming. I'm very lucky in that William takes his job very seriously. They measure the borehole flow meters on a daily basis. At the moment, we visit the site every 4 months. It started that we were visiting it on a monthly basis, but as we've got more and more data, and as we understood the aquifer more and understood the water patterns more, there's been less and less of a demand for us to go into site. We also have data loggers, which I'll talk to you about in a moment, that collect data in our absence. Now we're really more interested in understanding the pattern of how those boreholes are used. So we have 3 major boreholes 3 and 4. They remain the backbone, and they're the workhorses. These are the 2 boreholes that supply water in the summer months when the demand is high. They're sometimes backed up by the smaller boreholes. This is a slightly old slide where borehole 8 is still being used, but the lesser boreholes are borehole 6 and 7. And borehole 9 is predominantly used in winter, where we rest boreholes 3 and boreholes 4. And borehole 9 is then the mainstay in winter. So this is a graph of how Arabella's water use has changed since the early days of 1998. So the first 10 years, it's an average using all the data that we have. And then after 10 years, it's a 10-year move in average. And you'll see that, a couple of times we've had very high demand. One of these years, there was a big fire that swept through and a lot of water was used in the firefighting process. But by and large, we have quite a consistent water use of around 250. So we remain well within the permitted use of water that we allowed. The interesting thing here is to see the devastating effect of COVID on all 3 parts of the estate, where this is substantially less water use than what we've seen in the past. And I think it's a very common thing with anyone in the entertainment industry on how they've been affected by COVID, and hopefully that can change and business can return to normal in the short term. So in these 20 odd years that we've been measuring groundwater and monitoring groundwater at Arabella, the tools that we've used have changed quite dramatically. So we originally started with a system with a mechanical system which had a float, and then the turning of the wheel was logged. We then moved through to a global logger, which is the system here where the logger is connected to this device here by means of a vented pipe. So there's a small hole and it would measure air pressure. And now we're on the 3rd generation where we lower this device down. It's about the size of a cigar, and it measures the pressure at the height that you hang it, and we pull it out and download it, and we can draw graphs, something like this. This is a graph from borehole 3, one of the mainstays that I've drawn from October 2004 up to the end of last year. Hydrological years go from October to September, and I plot them in that way. The red dots that you see are our visits, where we go along and check that the data logger is working well, and we can calibrate the data that we have, and you'll see that all 3 versions of the logger work pretty well. We have a couple of problems from time to time where they fail and we lose data, such in this period here. But we've now got more than enough data to understand how these patterns work. This graph is quite a busy graph. So if we go down and look what it looks like in a year, so this is the previous hydrological year, and we can see that when we turn the pump on, the water level drops exactly as we had expected. and then we turn it off and it recovers. What this graph really shows is that borehole 3 is used from December through to April on a regular basis. And then outside of this, this is all where it's, the borehole's turned off, and then it's brought into production for a short while just to make sure that everything works and they don't have problems. Boreholes are a little bit like boats. You need to use them to make sure that they remain in good condition. If we zoom back in further, so this is a 4-week period, we can see how the borehole is operated by Arabella. It's not run constantly 24/7. So if we could, that is the pumping pattern we would like. You turn the borehole on and leave it. So this turning on and off, it introduces oxygen into the subsurface that we don't really want. But unfortunately, us theoretical hydrogeologists don't have our way, and we have to be driven by the water demand of the client. The client is very well aware of the need to manage the aquifer in a certain way, but the realities of life are such that we can't do this, and we have to work within the constraints that we have. So this is a layout of the management plan that we have for Arabella, where we run borehole 3 for a month in summer, and we run borehole 4, and borehole 6 and 7 act as backups if it's needed. And we alternate that throughout the summer, and we can see that on the groundwater level graph that's how it has been working. And then in winter, we turn off boreholes 3 and 4, and we then revert to borehole 9, as I explained just now. What is very interesting for me is that, you know, I lay out these things and I think about the way we would like them to be and what the ideal would be. And often the borehole that is being used is driven by whether Petrus is on duty or not. Now, Petrus doesn't have a driving license, so he can't get to borehole 6 to manage it. So if he's on duty on a weekend or there isn't a driver available, borehole 6 can't be used, and they have to use one of the other boreholes. It's for me just quite an amusing way, is that sometimes we think we know things and we want things done the way we want them done, but real life doesn't allow us to behave like that all the time. I must admit, though, that William works very hard to follow this plan, and by and large he gets it spot on. What I'd like to share with you now is 3 little bits of things that I've learned in my 20 years of working at Arabella. And the first one revolves around borehole yields. So the way we would typically get our first indication of how strong a borehole is what we call the blow yield. When we drill in a borehole, we pump air down into the hole, and that drives the hammer. But that air that goes down also brings out the cuttings and brings out the water. Now, I know I'm telling most of you things that you know so much about you've already forgotten, but that blow yield is our first indication. And in a fractured environment like this, we got pretty impressive blow yields. When we started testing them, specifically when we did a constant discharge test on borehole 3 and the step drawdown test on borehole 4, they were supporting that information that these 2 boreholes could be pumped at about 25 liters a second. But once we brought those 2 boreholes into production, we soon learned that, oh no, this is a bit high. The boreholes can't produce that, and we need to drop the production rate down to about 10 liters a second. And for this reason, we didn't do a lot of pump tests on the remaining boreholes. We did step drawdown tests on borehole 8 and 9, but we felt that there wasn't a direct correlation between the outcome of the pump tests and what we observed under production conditions. And I think this all relates to drilling into a very transmissive fault zone. But as soon as the radius of influence moves away from that fault zone, lower levels of transmissivity come into play, and they are actually the ones that control the production rates. So while we might be thinking we're getting good boreholes at 10 or 20 liters a second, our good boreholes produce about 10 liters a second, and the lesser boreholes may be a little bit more than 5 liters a second. So that was a learning point for me to understand the difference between the field tests that we do and how the aquifer system performs under production conditions. Right. The second learning point that I've taken out of my time at Arabella is we always get asked, well, how much does the aquifer produce? How much can you get out of the aquifer? And it's actually quite a difficult ask to confirm what the sustainable yield of an aquifer is. So Arabella is an interesting one. If you take the fault, the western limb of that Horston Garden structure, it almost acts as a long pipeline that water from the surrounding rock can drain into that, and then it can move quickly into the fault, and then is transmitted quite quickly. So you're working out exactly where the aquifer is and how big it is quite a challenging task. But what we see in monitoring the groundwater levels in borehole 5, when it's only been used as a monitoring borehole, is we see that there isn't a declining trend, but we see that there are different levels. And if you look at the rainfall pattern in these gray bars, when the rainfall is high, you seem to have one level. We have a lower rainfall, it seems to drop to another level. When the rainfall goes back above average, it recovers almost instantaneously, and by the end of that winter, it's back to its winter high. And then you'll see this lower level here for the last 5 years, where we've been impacted by the drought that's affected the whole of the Western Cape. At the end of last year, we had some good rains above average. The average rainfall for Arabella is about 800 millimeters. And last year we got about 900 millimeters, and you can see how quickly the water levels recovered. I was out there the other day, and still with 2 months to go of the winter recharge period, the water level is now back to the same level as it was shown here in October 2020. So I'm expecting the water level to be higher than what it was previously. And this relationship between the water level and the rainfall reminded me of some work that a former mentor of mine, Dr. Koch at the Department of Water Affairs, he used to draw these graphs, and he drew these graphs on spring flow, relating rainfall to spring flow. And so I said, okay, well, let me try this graph on rainfall to the end of the winter recharge period water high level. So the highest water level we recorded. And I got this surprisingly very, very good relationship that now starts to allow us to see where the water level should be based on rainfall. And if the groundwater started to be used unsustainably, we would expect the relationship to start drifting away from what we see here. But as all good scientists, just when we think we understand things properly, something comes along and reminds us that we're not as clever as we think we are. And we've got borehole in 2006. It's nowhere close to what the expected relationship is. And the only way I can explain this is that borehole 6 was a once-off period of very low rainfall, and we still have a hangover from the previous good recharge periods. And the winter high that we observed in 2006 hadn't been affected by that single event of a low rainfall. I get very excited every year when I'm allowed to plot this diagram to see, are we still on the money? Is the relationship still holding? But I think it's a useful one for us to be able to monitor the groundwater supplies with. The third issue that I can share is we've got an extraordinary amount of water quality data. We don't do full analyses, but every time we go and visit Arabella, we measure the pH, the electrical conductivity, the sulfate, the iron, and the manganese, and we can see these patterns. What we definitely don't see is a deteriorating water quality. We do see an increase in variability, particularly when it comes to borehole 9, and borehole 4 also shows a degree of variability, particularly in the pH. The EC, that variability it's a real significant variability in that, you know, it goes from somewhere around 20 millisiemens per meter, which is as good as any municipal water supply you'll get. And borehole 9 fluctuates quite a lot, sometimes going up to 35. But that variability is not something that you would taste unless you were a very discerning taster. More importantly is looking at the iron and manganese, and we do see a couple of peaks. You'll see there at one stage borehole 4 gave an iron concentration of over 30 milligrams per liter, as did borehole 7. But by and large, you almost get an impression that the iron concentration has been dropping slightly. What we definitely see during the drought from about 2017, 2018, 2019, both the iron and manganese have been more stable. They haven't jumped around as much, and they've been slightly lower. So my thoughts around this revolves around the recharge process and the introduction of oxygen into the system. So it'll be very interesting to see what these chemistry levels do in the next period, when we know we're getting good recharge, and we see that from the groundwater levels, particularly in borehole 5, which we use as our health indicator. All right, my final point that I want to make about Arabella and my learning is this is a diagram that many in the environmental sector will know very well. Stephen Davies lives and eats and breathes this thing. But it says that, you know, sustainability is driven by social factors, economic factors, and environmental factors. And groundwater has often got a bad rap on how it's not being used sustainably and so on. But in the case of Arabella, this diagram has really come into focus. So that groundwater supply that they use has had a massive impact on the social standing and the economics of the region. So there've been at least 400 permanent jobs created by this development, and that's not an easy task to achieve those levels of job creation, and they've been sustained and grown slowly over time. There have been about 1,500 to 2,000 temporary jobs around the construction. So this obviously talks to the economics and the social well-being of the area. The social side of things, it's housing, okay, it's high-end housing, not low-end housing. It's about entertainment and the golf course. So the development ticks the social box. The economic boxes, besides the job creation, yeah, it's about the boost to the economy of Claremont, Hermanus, and the general region of the people that come into the region either to play golf, to spend time at the hotel, or generally live there. You know, Arabella, it's not a permanent thing, but they have a big golf tournament every year, the Nelson Mandela Challenge, I think, or the Nelson Mandela Cup. They're hosting the Lions. They provide that kind of service. And then we go into the environmental side of it. And at the outset, I was telling you about this derelict, alien-infested piece of land, which has now been turned into something. Recovering that badly damaged environment is not an easy task. It's an expensive process, and there are not a lot of people that stand up and stick their hands up and say, we'll rehabilitate that environment. And Arabella has provided an alternative towards that. And they work quite hard at the alien clearing and trying to make the place better. We certainly don't see any sign of overuse of the groundwater resources. In fact, my conclusion is that the resources are being used well within their capabilities. We were possibly very lucky that Arabella came into being in the early stages of what is still called the new National Water Act that came into being in 1998. So they started using in groundwater in the window that the department recognizes for existing lawful use. And we have all the permits and the requirements, the legal requirements are met. Every year in November, I submit a monitoring report. Initially, it was to the Department of Water and Sanitation. Now it's to the Breede Gerritz Catchment Management Agency, reporting what our findings were in terms of the water use, the problems they experienced, and so on. So Arabella operate in a very responsible and legally required way. And it's always nice to be involved in projects that have that kind of ethos, and that's what they want to do. What is most important for me is that, you know, we always think people that are developing things are out to do damage. The Arabella, the homeowners association, are as keen as anyone else to make sure that the groundwater is used sustainably, because this is where their investments lie. So they might not have the environment on top of their mind, but they certainly have the economic sustainability there that drives them and makes sure that this groundwater supply is used properly. All right, so in conclusion, what we've learned is that the boreholes are an asset. Without these boreholes, Arabella just simply wouldn't be there. And the boreholes are used and managed in a way that allows the boreholes to continue to be an asset and allows for Arabella to remain a viable entity. We've got 24 years of groundwater use and management. The amount of detail that we've got is unusual. I won't say it's unique, but it's certainly unusual. And it's been a privilege to be able to be part of this for so long. It is very clear that the groundwater has been used beneficially and sustainably, and that the water demand of Arabella Estate is being met and within limits. And this all wouldn't have been able to happen if the management of the groundwater supplies to Arabella Country Estate weren't managed in a very good manner. Right, I think that's all I have to say. Thank you very much.
Thanks, Roger. That was fantastic. Do you want to unload or share your screen, and then we can open up the questions and answers?
Let me work out. I can do that.
Fantastic.
All right.
Okay. All right. Okay. That was really excellent. And most of all, I love your very last point about management. And you know, credit to yourselves and Arabella, and credit to our Hermanus municipality. And if only that sort of approach applied to every one of our municipalities, be it Kimberley, Lichtenburg, Standerton, you know, and the list is endless. With a plan and management, you know, those sad towns certainly shouldn't be like they are today. Anyway, that's my first takeaway, but let's have some questions from other people.
Thank you.
Right, who's first?
Can I ask something, John?
Yeah, go for
it. That graph of yours, Rogers, of the sustainability of the 2006 outlier, yes, made me wonder if, you know, you have a bit of a hysteresis effect with maybe one could actually look at 2-year periods instead of just 1 year, just to try and smooth it a bit and see if you don't get more information out of it.
Thanks, Peter. That's a great idea. I'll try that, because it's always nice to have a strong relationship that comes out, but it's never nice to have the one that doesn't play ball. So I'll give that a bash later today.
Okay, next person. Roger, just a question from me again. Where's your recharge coming from? Is that sort of coming off the upslope to your, what's it, sort of northwest, is it? I mean, so you're sort of sitting on the edge of the valley above the estuary, and you've got those faults well mapped out, but there's got to be water coming from somewhere.
Yeah, it's all the rainfall that falls on the exposed Table Mountain group on the western part of or western side of that fault. So yeah. It's a massive catchment area. It's 40 kilometers long by at least 5 kilometers wide.
Okay. But again, it also raises the question that it's a critical area that should also be looked after in the general scheme of things. It's the same as the Hermanus Aquifer and protecting and looking after Fernkloof and that upper part of Fernkloof where most of the recharge comes from.
Correct. Yeah.
Okay. John Weaver. John, if you can unmute yourself.
Okay, yeah, Roger, thanks for an excellent talk. I've heard you talk about Arabella a few times. It's the first time you've given such a big and full comprehensive talk. Thank you very much. Thanks. The one thing that really struck me was how impervious and oblivious both the aquifer and the usage of water was to the drought that nearly caused day zero in Cape Town. I couldn't see any evidence in the Borehole 5's graph of water levels dropping dramatically even further because of the drought. And I saw no change in people's consumption, in Arabella's consumption of water, which to me is a wonderful demonstration of how groundwater is relatively impervious to drought conditions.
Yeah, thanks for that, John. I think there are two sides to that story. So with the onset of the drought, I had to give the Homeowners Association an update. So they increased the frequency of monitoring back up to 2 months instead of 4 months. So I went every 2 months to go and see how things were working, and I had to give them an update after each visit. So they were acutely aware of the risk that they were facing, and they implemented an action to say, well, are we facing a real threat? And if you look carefully, you can see that the water level did drop a little bit. It sort of had a slight reset, but it wasn't a continuing decline. It reset and then it stabilized. The other part of that is Arabella managed their water consumption very carefully. They have internally they have cost structures. So the hotel pays for its water, the golf course pays for the water, the homeowners pay for their water. And every time that they were hosting this annual golf course, the Nelson Mandela Cup, whatever it was called, there would become the big fight between the management of the facility and the golf course guys, because they wanted water to make their golf course look good. And they had these structures in place where they could control it. And they made sure that those structures were firmly in place during the drought to make sure that they were continuing to use as little water as they could.
Okay, next one.
Roger, can you tell me the material that the impeller is made of?
No, I can't do that. I think it's stainless steel. I'm not sure though.
Because I know somebody up there in the north that's manufacturing polyurethane ones. I was thinking that if you have something that doesn't react, whether that would lengthen the pump life and the cycle of having to clean it.
Yeah, the pump side of things is a little bit outside of my area of expertise, but I certainly, as we try and rehabilitate bore 7 and we have to replace the wet end, I will ask the pump guys to look at that.
Yeah, if they can pass the dimensions on to me, I can give this guy, because he develops specifically for certain pumps. It's done here and overseas. So if it's possible, then he can design a impeller for them.
Okay, thank you.
Can I ask something about biofouling, Roger?
Yes.
Will it make a difference if, we're talking about the oxygen and it getting to the aquifer? If you limit your level to not go down below where the water starts ingressing into the bore. I mean, you mentioned that one bore that went right down to 255 meters before you actually struck the big water.
Yeah.
So I would expect that one to, probably not to biofoul, and I'm not sure about it, but because the oxygen wouldn't go down that far down if you only stick to the top 30 or 50 meters or whatever of the bore.
Yeah.
Any comments?
That's exactly what we try and do, and that is the collective wisdom, that you restrict the drawdown, so that you don't allow parts of the bore to be exposed to oxygen, and that's the way that we understand it. But recent work that we've been doing, particularly related to the drought work in Cape Town, is starting to suggest there might be something else to it. For me, it is instructive that it's bore 8 and bore 9 that has had this problem specifically. And I'm wondering if it's not related to the introduction of microbes in the drilling process, that the drill stems hadn't been sanitized, which is not, it's never a requirement. It's not something that we do, but I wonder if there's not some cross-contamination that took place. The other interesting thing that happened with those two bores, we drilled them soon after I was involved in a court case where the way we drill bores and we test them came under scrutiny, and it was a phase where I went through that. We did bore straightness tests, and we introduced this 6 meter long stem, and if it could be passed down to the bottom of the bore, then we said the bore was straight enough. And I'm now starting to wonder if there isn't some other mechanism of the bacteria getting into the bores, but no one should quote me on that. It's just a thought.
Okay, we got some young people here. Kukuleni, don't any of you have some questions, answers, problems that you need Roger to solve? Okay, and Roger, just looking at this model, I mean, where else is it applied, across the country, particularly in small towns? It just strikes you when you look at the problems, and you will know Grahamstown that they've had there, and, to their credit, you've had people like Gift of the Givers come along and drill boreholes, but it begs the question is, if you have this really well-managed model, that we should also be looking at probably similar sort of situations in more of these, more remote areas, small towns, places that struggle to have consistent water supply. And here's a great example. So how far is, or where else has it been rolled out?
Unfortunately, I don't have any good examples that I can give. I'm sure some of my colleagues might be able to have that. the big difference here, and it's to a degree work that I've seen, or the way we respond that I've seen in the last 4 years. This is a private sector initiative. They're not driven through procurement processes, and if something's got to get fixed, well, it gets fixed. You know, in those early days when the iron treatment wasn't working, it was one phone call from the client, and the problem was solved. Everyone jumps in, and it's got a different mechanism that that drives it. And I mean, they're on top of it all day long. The fact that they go and do daily measurements of the flow meters is an indication of how important it is. Many of the municipal systems that I've been involved in, they fail because they don't have this hands-on management and monitoring. We've seen in this case in Arabella, you start very intensely, and then once you know the system and everything's running properly, you can step back and slow down a little bit. But it's that process of getting it going, getting buy-in to the system and maintaining it is the challenge. And the municipal suppliers don't have that same intensity.
Yeah. No, you say it all fascinating, and it's a lesson that we need to get more and more private enterprise involved in this country of ours if we're going to fix it and turn things around.
I would like to give a little bit of a shout out to the Western Cape government. What they did in the drought, the Department of Local Government, they assigned a hydrogeologist to each municipality. They said, okay, Roger, you need to go and look after municipality X, Y, and Z, give them whatever advice, check what they need. So that what they did in that drought period, they made sure that the municipalities had the expertise at hand to make sound decisions. A lot of the decisions are made on beliefs and half thoughts and half knowledge. And the way that they tried to tackle it in the drought was to provide local municipalities with that expertise. And I thought that was a fantastic initiative.
Excellent. So it's all the more reason to start exporting the Western Cape models. Anyone else?
Bill McKechnie has got a question. Unmute yourself, Bill.
Yeah, okay. Hi, Roger. Great presentation. Thanks very much. And
thank you, Bill.
Working for Snowdon, we do a bit of environmental and water monitoring on many of the projects that we work on, the longer term ones for the banks and so on. And what strikes home is that you virtually need 5 years of data before you can really see the trends coming through. So it was very interesting looking at what you were presenting, and it was very well presented. Great. On the fouling of the boreholes, I remember when the Venetia well field was developed, it must have been the late 1980s, early 1990s. There was a huge problem with the pipes, the water pipes from the well field to the mine over a distance of, I can't remember, say 20 kilometers or whatever it was, being fouled and in fact being corroded by, and as I recall, it was anaerobic bacteria developing in the pipes. No one could understand where it came from. I lost contact with it, but a guy who probably would know something about it is Hans Hanweg, who now lives in, he was there on Venetia at the time. And it would just be interesting to find out. It might be worth approaching De Beers. They've been operating that well field now for, as long as Venetia has been open, now 30 years. So they must have a lot of information on data on that. But as I said, I've got no more contact, but it's maybe worth a look.
Excellent idea. Thank you very much for that, Paul.
Okay, Henny, I think we sort of running out of steam. Any last questions for Roger or discussion, comments?
Yeah, I've got one. John Weaver here again.
Hi, John.
Just with regard to biofouling and pipelines, I'm very much involved in the bottled water industry. And in the bottled water industry, the great majority, except for one or two, use water from boreholes for their water supply. And they all have all properly run bottling plants have a program of pipe disinfection over the weekend. So in other words, they pump the pipeline full of a whole bunch of strong chemicals to make sure that bacteria don't grow in the pipeline. Otherwise, you get a major problem when you bottle the water. You get little chunks of this biofilm breaking off ending up in your bottled water. So yeah, it's not just water supply. It's other places that have big problems with biofouling and pipelines. Thank you.
And presumably, if you're mixing your water with gin or whiskey or something, that's not a problem.
Definitely not. You've solved the problem.
Gerry, has your question been answered, Gerry van Aswegen, about the bacteria in groundwater?
That's very interesting. Can you hear me?
Yes.
Well, the question would be, would all the bacteria involved here be introduced, or could there be natural bacteria in the groundwater that could be a problem? Even old water.
This is outside of my area of expertise, but one of the things we did in 2000, and my friend John Weaver was the chair or the co-chair of the organizing committee of the IAH, the International Association of Hydrogeologists. And we had an international conference here in Cape Town in 2000. And one of the keynote speakers at that was this whole world of learning about bacteria in groundwater. You would think it shouldn't be there. It's been covered for millions of years. And they were finding some very interesting things in the States. We've got, soon after that, we started having the ability in groundwater. You must always remember that groundwater is very much the poor cousin when it comes to mining. There's far less money available for hydrogeological investigations than there is for mining investigation or resource investigation. But we now have the ability to put cameras down boreholes, and it's now commonplace. But in many boreholes, a chap by the name of Eddie van Wyk was finding these Steiger pods. They look like a prawn, but they're translucent. They've never seen the light of day, and yet they're living in the underground. So there's, I would argue that there's a strong chance that they're in situ, and that's where they come from. But my comments are driven around that. Why is it these last two boreholes that we have in it? The first boreholes that we did in 2000 and in 1998, boreholes 3 and boreholes 4, don't show signs of biofouling. And these boreholes that were drilled in 2008, if I remember correctly, they're the ones that are showing that. So I don't think it's a straight line, and there's a wonderful study there to be done by a student with a little bit of energy.
Great, and Christo, are you still on the talk? I mean, if you got our emails, we'll gladly introduce you to Roger.
Thank you, John. Yes, I am still here. Okay. I would really like to engage with Roger. I just got appointed now recently, 1st of July, as a scientific technician. I've been based in Limpopo most of my year's experience in Mpumalanga, and previously in the Northern Cape. I used to work on use licenses majority of my year's experience. So yeah, I would like to really engage with Dr. Roger to get more insight and info on how to go about doing monitoring, knowing that's going to be like something new to me. going into the field and collecting data and basically uploading it and disseminating it to head office.
Okay, fantastic.
Okay.
So I'm sure Roger would share his experiences, and even, you know, he probably needs a field assistant once in a while, get you out there and you can learn from him directly. And the same here applies to any of you other young students there. If you guys are needing a bit of help or want some information or previous presentations that Roger's done, you know, please feel free to contact us. And Henny will probably add Roger's presentation will be on YouTube early next week. Okay.
Yes, listen, Ruben Lazarus just wants to know if turbulence caused in, during the drilling doesn't affect biofouling.
It could be. At that time, you're introducing a lot of oxygen into the system. That's how the drilling process works. It could be a contributing factor, yeah.
I'm viewing Graham's screen here. Graham, is there anything you want to share with us?
Okay, let's wrap up, Henny.
Okay, thank you very much, guys. We see you next week for some more water everywhere and not a drop to drink.
Okay.
To mention that I would love to hear a similar talk about the Hermanus boreholes and the whole process. It'd be nice to hear a similar one.
Okay, who's that? Graham Palmer?
That's right, yeah.
Are you well?
I was on a committee that was looking after the Ferncliff and, because of the boreholes, but I was only on it for a couple of years, but I'm not sure who you'd get to do it, but it would be really interesting.
Okay, no, well, I mean, we've got Dylan next week on the Steenbras, and, we'll probably then get him to do Hermanus again for us. He's done it before and very well. Sadly, of course, Chris and Rowena are no longer with us, so we can't get them, but we'll certainly put that on the list, Graham.
Yeah.
Okay.
Right,
Thanks.
thank you, everybody. We see you next week. Bye-bye then.
Thanks, Roger.
It's a pleasure. Thank you very much, everyone.
Okay, thanks, everyone.
Bye.
Have a good day.